I'm CK. Last night I built this Elenco XP-15 DC power supply, and it was a fine build. The video should be up by now, unless I made a mistake. I shouldn't have. But the problem is the voltage selection knob potentiometer doesn't really give you a good idea of what the voltage you're getting out is. In fact, when I tested it, if you look at that video, this runs from 0 volts to 18.5 volts, not the 15 that's marked there. So using this, you would have to drag a meter around to make sure you got the right voltage to whatever you're trying to apply it to. I didn't like that, so what I'm planning to do tonight is taking this display and adding it somewhere on the box. I haven't decided quite yet where it's going to go, so we can have a voltage readout. So you don't have to worry about setting this little knob to some magic position. You can actually read it out. And I'll show you where to get this and how to set it up and all that. And it'll be kind of fun. And I hope you enjoy the video. So the goal is to get a digital display of the voltage on the front. Or I could put it on the side, or the top. I actually don't know what I'm going to do yet. I'll see how the spacing goes. And get a digital display so I don't have to rely on guessing where this particular potentiometer is pointing. And you're saying to yourself, but CK, that's just a display. What else do you need? Well, that's actually not the case. This is a DSN-DVM -368. That's the part number of this, and what it is, and I'll put a link of a real good description of it in the description field. What it is, under this circuit board, there are 2 chips. This is a full digital voltmeter in a little package like this. It costs between US $1.50 to $3, €2, whatever. You can find them a lot of places at any local, whatever your favorite electronic part retailer is. So this is a DVM that goes from 0 to 30 volts, and since this goes to 18.5 volts, that'll be plenty to cover it. Now on the back there are inputs, and then there are 4 jumpers. These 3 tweak the sensitivity of the device. I'm not going to mess with any of that. This one, so right here, this is ground. This is the voltage to be measured, the positive voltage to be measured. This is the voltage that powers the device. Now if I bridge that jumper, then the input voltage, the voltage being tested, also drives the device. Now the penalty you pay by doing that is you can't go below about 4.5 volts or the device will just turn off. So ideally you'd want to put your supply voltage here, and then your voltage under measurement here. I'm not sure which one I'm going to do yet. I want to take this apart again and see where I may want to tap. I'm probably just going to bridge that and just use 2 wires going off this. So I think I'm going to be able to do that, but I don't know for sure. So first thing we're going to do is take this all apart. And of course my goal of mentioning everything about the chip is, or little part, is that makes it a lot easier. You don't have to do anything. You just hook up 2, you can just hook up 2 wires, and suddenly you have a voltage readout. Take the back off. Now we'll take a look in here and see where we can mount it. We can, I'm going to see, does it fit? It doesn't fit really well right at the leads. I think it may fit between the leads and the power LED. Maybe, maybe not. I'm going to do something to help me figure this out. I'm going to take the device and a pencil. If I can find my pencil, there it is. And I'm just going to draw an outline of it. It's giving me a little bit of space. Now get a straight edge. Little X-Acto knife. I hope this is sharp enough. I'm going to go change the X-Acto knife blade just because I can. Nice new blade on my, and a nice cutting surface to cut on. Now that's the size, so it's easier for me to work with this, manipulate this around. That should actually work, even though it'll make the plastic there a little thin, but this is not, it's not supporting that. Actually, I do like it right up here. So I'll try to put it right up there. See where that looks like. I think that is, it's under the outer winding of the transformer, but it will fit in there. And I'll be taking the board out while I do some cutting and so on, so it's not that big a deal. So if we put it right there, let's do another measurement here. It's 22 millimeters long. So with it being 22 millimeters long, the midpoint is here at 11 millimeters. I'm going to do that twice. Now connect the two dots. And that's the midpoint. I think it is. Let me double check. 11 millimeters there. A little more than. So it will be the inner edge. This side. That's the midpoint. I could also put it vertically. I could put it whatever, but I think this is going to be the right place for it, and that'll be above this center index mark on the line there. So that's what we're going to do with that. I'm going to pull the circuit board loose. I'm not going to disconnect it completely because it's soldered in place, of course. The cable, the wires go into the posts, so I'm not going to take them off. That gives me enough space in here. So I'm going to measure, now I'm going to measure in here to see what I'm doing. But no, I think it'll work. I think that'll work. Just have to be careful when I'm cutting to not be too horrible and crash into the transformer. So I'm going to move to a different part of the shop, and I will be back with you in a minute or two. So I'm over on the mechanical side of my shop because I may have to use my Dremel tool or whatever over here, and I don't like to have all that schmutz over in the electronic side. Now, I just did this and I turned the camera on, but the camera didn't have the data card in it, so it didn't do anything, which is good. But what I did was I just took my X-Acto knife and scored along the edges of that box that I had made. And you may be able to see here that it's all cut out. I'm not critically concerned about the exact size. It could be a little bigger, it could be a little smaller. I'm not going to fret about that. Now I should be able to get this upper label part off, and then I'm going to decide how I'm going to cut the plastic underneath. I think I need a different tool. 1 second. Mainly, I don't know whether I'm going to need to use a Dremel tool to cut through that plastic, or whether I'll be able to do it with the X-Acto knife. But first thing will be to get this part off the plastic thing we already stuck down here, but the glue's really good. There it comes. Let's see if I can get a fingernail under it. Not yet, but let me keep working it up a little bit. There we go. That will be good. And I shouldn't actually peel that up with my finger because I'll tear something wrong. This is the only problem with having two main areas. I have to walk back and forth. I need to, different issue. Let me peel this up again and get my small needle nose in there. So that came off okay. Now let me take a look in here and see how tough this plastic is. Let me double check my little index box, and it'll fit in there. If not, as I mentioned just a half a second ago, I think I can go ahead and grind or whatever we might need to do. But now I want to see if I can cut this plastic without hurting myself. Well, I could, but I don't think I'm gonna. I'm gonna go get my Dremel tool back in a bit. So I got my Dremel tool, and just for historical reference, this I bought in 1978 in Rantoul, Illinois at the Slot and Wing hobby store. Who knows if it's still there? So it's older than most of y'all. Now I'm not using a cutting wheel. I'm using a pointed bit that I'm going to try and drag along that. Because I don't want to use a cutting wheel because it'll. I don't want to go past the edges. This is more precise than that. And yes, I have eye protection on, just to be clear. So there's the rough hole. And yeah, it looks like we've got plenty of space under the transformer. That's one of the other reasons why I didn't want to use the cutting wheel, because I didn't want to overshoot and get inside that. So I'm getting another Dremel tool. Hold on a sec. I'm going to be grinding off some of this rough stuff here. Okay, so that will be all I'm going to grind with the Dremel tool. Now I'm going to go get some files and dress this up a little bit more. I'm also going to clean this up, so I'm going to be off camera for a minute. So I've got a flat half round here and a triangle, so I can get these corners a little more square. And there, that will go in just perfectly, even though it does look a little cockeyed, doesn't it? Huh. I'm not going to worry about that. If it's a little off-center, it's a little off-center. Now I need to put 2 holes in for the screws. So let me go get a drill. So that didn't work out. There's just not enough material there to drill. So I'm just going to press fit this through. I may add some epoxy to it when we're all done. I'm cleaning some of the plastic sprue off there. So what are we going to do next? I've got 2 pieces of wire, 22 gauge stranded. That I'm going to use to hook this up. And what I'm going to be doing is I'm going to use the input as the power. I don't care about the voltage level below, say, 4 volts. And quite frankly, I can always change it if that really drives me crazy. So what I will be doing is we're going to start by finding a piece of solder amidst all this, and not that piece of solder. That's a huge piece of solder. And I'm going to bridge this jumper so it's powered by the input, not by a separate .5-volt power supply. And then I'm going to take this red wire, heat up the solder that's already there, and have the wire sink into it. I'll probably add a little more solder to that in a minute or two, and do the same thing with the ground wire. Like I said, I'm going to add a little bit more to this guy here. Of course, I let it get away. Now that's fine. Now just for fun, let's try it on a 9-volt battery that I have lying around on the desktop. So this should power it up. And there we go, 8.8. So we know that works and we know our connections work. So what I'm going to do next is place this through the opening I made. Get under the transformer, get it in there. It pretty much press fits in place. So it'll look kind of like that. It goes out quite a bit, doesn't it? It'll stick out quite a ways. I don't think I care about that. If you were to care about that, you could put a spacer in. I might do that later, but this is just, right now we're just doing this proof of concept, getting this all running. And I'm going to take the wires and bring them over to the side, and then I'm going to take the circuit board and put it back through, make sure my LED is still aligned. Circuit board is almost back through, but it's hanging up on something. It's probably hanging up on, oh, is it not getting the, now we'll get the washer and the panel nut. Now, I'm just going to go in parallel. Just think of it as this would be as if you had a meter plugged into your input all the time. So I'm just going to burn my thumb, and then I'm going to heat up this solder again. Okay, I was just watching the video playback of this and realized that when I was soldering over here, I was completely out of frame, so I decided to come back in. And what we've done is we've taken the ground wire, which is the furthest right on the little display module, and I soldered it to the black post, and I took the red wire, put it on the input power line, which I had bridged before, and soldered that to the positive lead. So that's what I did. Okay, I'll put my wires back down. My meter display got pushed back again. I got to lock that down with some glue. I'll do that later. Like it. And I put a tab, drop a Gorilla Glue on this tab, and we'll let it set, and it should be fine. So now, when we plug it in, let me turn this light off. As you can see, because we're using the output power to power that, and the device, did the plug come out? Yeah, the plug came out. And the output, this device needs about 4 volts, 4.2 volts to run, so we got to get up to about 4-ish before it wakes up. There you go. We can take it down to 4.2, 4.3, so you can get USB power metered. You can't go below that. If you really want to do this all fancy, you could find another tap for this. I'm just going parallel here because it's easier, quick and easy, and this I'm never going to use it below 4 volts anyway. So let me put this little, just to make sure everything is still working. Put this little Christmas tree in here. And I think this needs about 5 volts to come up. Yep. I didn't make contact on this one. Didn't make contact on that one either. Golly, this is a These wires are so short, I'm having trouble getting myself where I want to be. There, you can see the little lights flickering, and you'll see the voltage is not changing. The displayed voltage is not changing because it's just in parallel. So that works very well. One thing I do want to check while we're here, let's see how this thing is tracking against my fluke. Oh, that's pretty dang close. This is 4.76. This says, 5.76. This says 5.73. Let me crank it up higher. 11.3, 11.28, 18.1, 18.06, all the way up, 18.7, 18.64. That's very, very accurate. So it's useful too. So that's it. Just a handy dandy little for a couple of bucks and a half hour's worth of work. You can add a digital display to it. Obviously, as I said, you can make the hole the exact size and put spacers in it so it's the right height. I just wanted to demonstrate the concept for you. And I believe it makes this much more capable and useful. You only have to drag this around the shop. You don't have to drag a meter around with you. So with that addition, this is a much more, in my opinion, functional device. So I hope you enjoyed the video on this little modification. Tell me if you want to see me modify other things with my big ham-fisted cutting and hacking and slashing.